Hi everybody, today we're going to be looking at an outcome in the grade 9 math curriculum. We're going to look at the question, what is a polynomial? This is part of the C-1 outcome. Students will be able to recognize and model polynomial expressions and identify its parts. This video will focus on recognizing a polynomial. Future videos will focus on modeling a polynomial using algebra tiles and then identifying its parts in another video. To start with, we would consider a polynomial a piece of algebra. And we also consider a polynomial to be something that is not an equation. It's not something you can solve. It's something you can perhaps simplify. It is only an expression. We'll talk later about the difference between expression and equation. Suppose I needed a rule algebraically that said I was going to take a number and triple it and then add 1. The polynomial that represents that would look like this. Triple some unknown number plus 1. Suppose I had a rule that said a number squared plus twice that number plus 3. Remember, squared also means times itself. That would look like this. It would involve the exponentiation of x. So a number times itself plus twice that number plus 3. Both of these things are polynomials. Polynomial by definition means many. Nomial means terms. Terms think of as things that are countable. Nomial means number or nominal, something I can count. So when I am doing a polynomial, I'm trying to count how many terms I have. This has 1 term, this has 2 terms, and this one has 3 terms. Now you might be able to tell just by looking at the numbers here what the rule is, but there might be people looking at it and wondering, well, why isn't this one 3 terms? It's got a 4, it's got an x, and it's got a little 2. Why isn't that 3 different terms? Well, because we define terms as being separated by addition. So this is 3n plus 1. There is an addition separating the 2 terms. This is x squared plus 2x plus 3. There is addition separating the 3 terms. Remember from grade 7 and 8 algebra that 2x doesn't mean 2 plus x. It means 2 times x. What about when you're subtracting? Well, this is also a polynomial. And I wanted to point out that if you think about this the same way you thought about grade 7 and 8 integers, you'd remember that 5x minus 3 is the same as 5x add negative 3. Remember that subtracting means the same thing as add the opposite. So I still think of this as being separated by an add. By the same law, because I can add together integers or numbers in any order I want, addition is commutative, I could say that 3n plus 1 is the same as 1 plus 3n. And one that's even more complicated, like this one, I can say that this 3-termed polynomial is the same if I added it in this order or if I added it in this order. And the fact that it has to be the same thing no matter what order I put it in is the reason why I have to think of this subtract as add a negative, because then I can change its order and say that these 3 polynomials are all equivalent to each other. That leads us to the idea that we have to define what a term actually is. In polynomial algebra, a term is a rational number times a variable to some whole numbered power. So in other words, it's a number that I know times a number that I don't know raised to some whole number power. Look at the 3 polynomials that we've been sort of talking about so far. If we look at these 3 polynomials, this 3n fits this pattern here because it's 3, which is a rational number, times a variable, which in this case is the letter n, and the whole number power on it would be 1. What about the 1? I don't see a variable there. Well, yeah, but you can think of it as the number 1 times the variable, say n again, but now it's taken to the whole number exponent of 0. Remember from your power laws that any number except for 0 to the power of 0 would in fact equal 1. The same thing is true here. I can think of this term as 1x to the power of 2. I can think of this 2x as 2x to the power of 1. all of these terms, whether they have a variable or not, still follow this rule. To summarize, and to give you an idea of what not to look for, polynomials, of course, are, like I said, expressions. They are not equations. This is an equation because it has an equality in it. That means I could solve for what x is. Here, the best I could do is perhaps be given an x value and then try to evaluate how much the entire expression is worth. Here, this is a polynomial because it follows the rule that every single term in it has a rational number, a variable, and a whole number variable, or a whole number exponent. Here, I have a integer exponent, and that integer is not a whole number. The other reason this is not a polynomial is because you can't break the rule that in polynomials, the variable can't be in the denominator. And 5x to the negative 2 actually is the same as saying 5 divided by x squared. You'll learn more about why that's true when you do power laws in grade 10. This is a polynomial because, again, it follows our rule of how terms work, but this one doesn't because you can't square root a variable in a polynomial. This is basically the same problem that this one has. The square root of x is equal to x to the power of 1/2, and once again, 1/2 is not a whole number. Finally, it said we could have rational numbers in front of our variables, and remember, rational numbers can be decimals or fractions, but when you're doing the variable itself, the exponent has to be a whole number, and these are not whole numbers. Therefore, those are not polynomials. In our next video, we'll be moving on to the other parts of that outcome.